In this video, we will be looking at an example exam question that covers specification point 1.2. But before we begin, let's warm up with a few more examples of distance time graphs and how we interpret them. First, which is fastest? Well, they're both travelling at a constant speed because the gradient of each is constant. However, one is faster because it has a steeper gradient. 2. Describe the motion. This one is travelling forward with a constant speed. We know this because the gradient is positive and it's constant. This one is travelling backwards with a decreasing speed because the gradient is negative and also decreasing. 3. Which has travelled furthest in 2 seconds? Well, this one has travelled further in 2 seconds as the distance on the y-axis is larger. 4. Greatest average speed. Okay, so they've both travelled the same amount of time on the x-axis. However, this one has travelled further in distance. This obviously means that it must have been travelling at a faster speed. 5. Calculate the gradient. We know that the gradient is the change in distance, which is given on the y-axis, divided by the change in time, which is given on the x-axis. The gradient, and therefore the speed, must equal 4 meters divided by 5 seconds, which gives us 0.8 meters per second. Okay, now time for the example exam question for specification point 1.2. First thing to note is the question is worth 8 marks, and so we have 8 minutes in which to complete it. Now for the question. 2 students, Jenny and Chow, are investigating motion. Jenny walks in a straight line and Chow measures the distance Jenny has walked in 10-second intervals. State 2 measuring instruments the student should use. Well, to answer this, we need to think about what Chow is actually measuring. She's measuring the distance and also the time in order to measure the intervals of 10 seconds. For distance, we can use a meter ruler or a tape measure. A ruler would be incorrect, as it is too small to practically measure the distance that Chow would cover in 10 seconds. For time, we can use a stop clock. Make sure that you use 2 pieces of equipment here that measure 2 different quantities. Next part of the question. The table below shows their measurements. Draw a graph of distance against time for this data. Okay, so if we look at the graph that we're given and the axes, we can see that they're already labelled and already have units. So the 3 marks for this question must be for plotting the points correctly and drawing a line of best fit. Things to consider when drawing a line of best fit. First, you must view the origin, which is this point here, as another data point. You can also see it listed in the table here, so don't forget to plot it. The second thing to consider is that if the points make a curve, you must draw a curve, not a single straight line or a line that goes from dot to dot. Here are some incorrect examples. In the first example, the student scribbled over the line too many times. Instead, use a sharp pencil and rub out if necessary. In the second example, the origin has not been included. And in the third example, the student has done a dot-to-dot method, drawing straight lines between the individual points, which must never be done. Here is an example of the correctly plotted points. And now we have to draw in the line of best fit. So, The line could be smoother, especially at the top, but it's accurate enough to get the marks, and it's definitely not worth scribbling over it or constantly rubbing it out to achieve perfection. This will only end up in it looking messy, jeopardises the chance of getting the marks, and also it will waste time. Okay, let's look at the rest of the question. Part C. How far has Jenny walked after 35 seconds? So, we must read the value off the graph. So we start with the 35 seconds, and we go up and across to give us 26 metres. Be sure to show this working out on the graph. This is especially important if the question asks you to use the graph to achieve the mark. Also, even if you've plotted the graph incorrectly, you will still get the mark if you show this point of working. Now time for the final part of the question. Describe how Jenny's speed changes during the investigation. Well, to do this we need to describe the motion from the graph, and to do that we always look at the gradient. We can see that the gradient is decreasing, and therefore the speed must also be decreasing. Finally, what feature of the graph shows this change? Well, as we've said, it's the gradient. That's it for specification point 1.2. Move on to specification point 1.3, and we'll take a closer look at the equation speed equals distance divided by time.